Warning: lithium metal is extremely reactive and may ignite spontaneously when heated. Chlorine gas is very toxic. This experiment involves very high temperatures. Avoid breathing in the fumes produced and work in a well-ventilated area. Hi guys, here is MIH. Recently, I was really into molten salt electrolysis after watching some of Scrap Science videos repeatedly. The ones that really intrigued me the most was actually the vid on making lithium. To be more accurate, he used a molten eutectic mixture of lithium chloride and potassium chloride, and electrolyzed it using a graphite anode and a steel cathode. I strongly recommend you check his video out before watching mine. Okay, so I found this video particularly attractive for me since Scrap Science mentioned that the melting point of the mixture is only around 360 degrees Celsius, which is among one of the lowest for ionic salts and easily achievable without any special equipment. Furthermore, my school's lab has a large bottle of lithium chloride, so I went out to try the reaction in my chemistry class. It worked fairly well, and we can clearly observe molten lithium being generated. I threw some of the molten mixture into water, which contained some phenolphthalein, and the solution quickly turned red along with hydrogen bubbles being generated. I was delighted by the result and how tame the overall process was, so I asked the teacher for some more chemicals and brought them home. Now we can start our actual experiment. I decided to do the electrolysis in a porcelain evaporating dish. It was placed on a tripod, and I preheated the dish using my alcohol lamp. Then I opened my can of lithium chloride potassium chloride mix that I salvaged from the school. Using a spatula, I mixed the salts well. The proportion of the salts by weight is 61% potassium chloride to 39% lithium chloride, which would give a eutectic mixture that melts at 353 degrees Celsius. There were a few large chunks of salt in it, so I crushed them up with a mortar. I then measured out about 10 grams of the mixture in a container. The exact amount isn't critical. I carefully sprinkled some salt mixture in the center of the dish. It first sizzled and let off a bunch of water vapor, and then quickly melted into a clear liquid. I kept adding the salt and stirring the molten mixture until the initial 10 grams are all added. The molten mixture was not very viscous, and it looked just like normal water. After most of the mixture melted, I prepared the electrodes. The cathode I use is the iron handle of this spoon. Make sure to use iron and not other materials. Scrap Science had already proven that nickel works terribly. I set up an iron stand and hover the cathode above the melt. Our anode is a carbon rod that I took out from a zinc-carbon battery. It has some impurities in it, so I first roasted it with my blowtorch until no more vapor can be seen. As you can see from the flame color, the rod contains some organic substance, perhaps an oil. After I'm satisfied with the result, I lean the rod on the side of the dish. The power supply is turned on and we begin to see bubbles forming on both the anode and the cathode. This is because water was present in small quantities and it gets electrolyzed first to form hydrogen and oxygen. The electrolysis had proceeded for a few minutes, and now the mixture is completely melted. A lot of bubbles are given off the anode, and a shiny material can be seen around the cathode. This is our bead of molten lithium metal. I checked the meter, and the current was about 1.4 amps, which appears to provide enough heat to keep the mixture molten and not solidifying. I tried blasting the lithium with a blowtorch, and it didn't burn, but a vibrant red flame color can be seen, characteristic of lithium. Using the blowtorch, I melted some salt solidifying on the sides of the dish. At this point, the cathode started producing a dark blue color that immediately reminds me of lithium dissolving in ammonia. Maybe it is actually something related to solvated electrons and complexes? I had no idea. Please tell me in the comments if you have any thoughts. After about 5 minutes, the mixture seems to grow a lot thicker. A lot of bubbles formed on the surface of the melt and stayed there. You can still see me feeding more salt into the cell. The extra salt cannot fully melt under the temperature, and I think this is what caused the mixture to thicken. A minute later, the extra salt seems to be melted, and the electrolysis proceeded on. You can see a few shiny beads of lithium near the cathode. However, I somehow decided to lift the carbon rod from the melt. This caused no current to flow through the cell, and the salt wasn't being heated enough. The salts then just thickened like before. When I put the rod back in, the gas produced resulted in a ton of splashing. It seems like that the cell just cannot be stopped once it started, or else the melt will thicken and splash molten salts everywhere when it restarts. I stopped the cell and took the iron handle off the stand. You can see that it is coated with a bunch of white salts. When the electrodes are taken out, there are a little bit of shiny lithium metal floating on the mount. After the iron handle has cooled down, I put it into some water with a little phenolphthalein added. It quickly gave up a bunch of hydrogen gas, and the indicator turned pink, indicating the presence of a strong base. The lithium metal was encased in the lithium chloride melt, and when the salt dissolves into the water, the metal was exposed and reacts with it. I then took the lump of lithium out of the water and blasted it with a blowtorch. When the water evaporated away, the lithium let off some bursts of flames, but unexpectedly it didn't burn very easily. As I mentioned, the lithium chloride tends to stick to the surface of the lithium and protect it from air even when it is molten. The beautiful red flame color was observed as well, which really saved my day. Because the salt solidified and I cannot get it to melt again, I decided to do the electrolysis in a crucible. Because the crucible is a lot smaller, it should retain heat a lot better. And it seems to go quite well. The current was 1.88 amps, far better than what we got before. Notice that the blue color appeared again, this time much more vividly. In this shot, you can clearly see the blue color appears to travel from the cathode to the anode. When I took the anode out, there are clearly a lot of molten lithium globules floating on the melt. I left the cell running for 10 minutes, and the current rose rapidly to 3.44 amps. The large current produced bubbles much more vigorously, and sprinkled salts everywhere. I took out both the electrodes and let them cool down. I then scraped the largest bead of lithium out the cell, and here is what I've got. I carefully removed just a bead and left the rest of the salt behind, and finally put the bead into a vial of Vaseline. This is our yield of lithium metal. It's just a tiny bit, but it was very shiny, and it even floated on the Vaseline, which tell me it's quite pure. After the success, I then tried several other runs, but unfortunately I wasn't able to isolate any lithium. In one particular run with a test tube, the current went up to over 6 amps and kept the mixture red hot for about a minute, even when I removed the alcohol lamp from it. The lithium seems to immediately burn up in the test tube and produce some very, very bright and beautiful sparks. It was an absolutely stunning view. Still, when the test tube cooled down, I smashed it and cannot find any trace of lithium metal. Also, I noticed that the process keeps destroying my stuff. The ceramic crucible produced a lot of cracks when it cools, and so does my test tubes. This problem can't be easily solved, and the only practical solutions are to either keep the electrolysis going for a very long time and produce a lot of lithium in one single run to compensate for the loss of the crucible, or instead to do the electrolysis in a metal container. Both of these solutions need a huge amount of the salt mixture, and I just don't have that much expensive lithium salt to waste. So I guess I'll just stop producing lithium from electrolysis and instead get it from lithium batteries. I will be trying molten salt electrolysis with sodium and maybe even magnesium in the future. Anyways, this project provided me many useful skills and inspirations about molten salt electrolysis, so it is a very good starting point for me. I would still call this project a brilliant success. See you next time!